This is Algebra 1, Lesson 6.1, solving one-step linear inequalities. Only thing different about inequalities compared to equations is you have, instead of having an equal sign in the middle, now you're going to be talking about not just one number, but you're going to be talking about everything that's either larger than or greater than something, or smaller than or less than something. You're going to solve them just like a regular equation, except if you have to multiply or divide both sides by a negative number, you're going to reverse the inequality. That'll be the only thing that'll stand out. First thing is the definition of a graph of linear inequality in one variable. It says the graph of a linear inequality in one variable is the set of points on a number line that represent all solutions of the inequality. For example, x is greater than 2. In order to determine if a solution is true, is you plug numbers into here. If we plugged in the number 10, for example, it says 10 is greater than 2. You're checking to see if this is a true statement. You're looking at its truth value. We're going to be using that term truth value a lot with this. That is a true statement. If you plug in something that's smaller than that number 2, 1, for example, and say 1 is greater than 2, that is not a true statement, unlike 10, which is greater than 2. When you graph the linear inequality, you graph x is greater than 2, simply like this. Just show, you don't have to draw a whole bunch of little tick marks like 1, 2, 3. You don't have to do all of that. All you want to do is you want to show, let me for all that to go away, you want to show its relation to 0. If 0 is right there, you want to show the number 2 as being positive. That means it's on that side. 2 is positive. So that side of the equal sign, this symbol right here, greater than, means you're going to bubble that number 2, and then you're either going to shade it in or not. Had it said greater than or equal to, and I know this is something coming from subject or lessons in classes that you guys took before, you would color it in. But since it's not or equal to, you simply leave it as an open bubble. And then since it says X and then it says greater than, you shade everything going the same direction, or you shade all the numbers that are larger than. So that's the graph of a linear inequality with one variable. We're going to move quickly tomorrow into graphing inequalities that have two variables. Okay, we know how to graph lines. It'll be a really easy change for you. The second definition is the equivalent inequalities. They are inequalities that have the same solution. Equivalent inequalities. So if you have 2 plus x is greater than 3, okay, this is equivalent to x is greater than 1. Notice they're both the same thing. It's kind of like if you solved one out. When we start dealing with two-step equations, or two-step inequalities, I'll always say that word equations just out of habit, but two-step inequalities, this will come more into play, the equivalence of them in the in-between steps before it's completely solved out. Those are considered equivalent inequalities. Example number 1 is writing and graphing a linear inequality. It says the speed limit you are traveling in a section of town where the speed limit is 35 miles per hour. Write an inequality to describe the speeds that are over the speed limit in that section. Graph the inequality. Now, when you're talking about inequalities, the words at least will come up. At most, at least, at most, not to exceed. You'll see stuff like that. You won't mess up with the word exceed, because if you've ever been in a car when somebody's gotten a ticket before, because most of y'all aren't driving yet, or at least driving legally yet, on a speeding ticket, it says that you exceeded the speed limit. Okay, so think about what it means to exceed the speed limit. In this case, 35 miles an hour is the speed limit. Ask yourself one question. Is it okay? And don't think super hard into this, like, well, my dad's got bigger tires on his truck. Don't think that hard into this. Is it okay to do 35 miles per hour? Yes. Is it okay to do 36 miles per hour? No. Again, don't think too hard into it, into real life. Cops not going to pull me over if I'm doing 36. That's not what we're talking about. It is not okay to do 35.1 miles per hour. according to this. So that's all you're trying to do is model this. Look at what it says on the left. It says, remember that an open dot versus a closed dot or a bubbled in dot or a blackened dot or whatever means that it has or equal to. So it says speeds greater than 35 miles per hour are against the law. So let S represent speeds over the speed limit. Speeds over the limit. So S, and it just acts like any other variable. They just said let S instead of X. Let S represent the speed over the limit. S is greater than 35. Again, it doesn't say or equal to, because 35 miles an hour is okay. And when you graph that, and again, you don't have to draw all of this, everybody. You've seen I actually erased all this to show you that you didn't need it. 0 is right there. 35 is somewheres over there. That's fine. And then it's an open bubble. Since 35 is okay. Remember, we're representing speeds that are illegal, not speeds that are okay. If you went the other way with the line, again, don't copy this next part. If you went that way with it, you would be represent speeds that are okay. The blue one, as I have it up here, is the one that shows things that are illegal. When you do this, don't do this, everybody. I see people do it. Don't do this. You're just asking to make a mistake, making a bunch of mess like that. Just do simply like I just showed you a second ago. Just go just like that. That's shading everything that direction. Okay. You don't have to copy this paragraph down. Take about 30 seconds and graph this one. It says Abu was sure that he did not score less than 73 on his algebra test. Write an inequality to describe Abu's possible score. Graph the inequality. Okay, let's take a look at it. It says he did not score not less than 73. It says write an inequality to describe his possible score. So you're not graphing x is less than 73. Look at what the directions say. This is where this will have to come into play too. Describe his possible score. So we know that we know it's going to be x and we know it's going to be 73 somehow. We need to fill in this blank right here with something. We know we're either going to fill it in with greater than or less than or one of those with a combination of or equal to with it. Okay, so think about the numbers that are in play. This is one of those instances where you're actually going to draw the number line. But think about where you are. It says that he didn't score less than 73. So he didn't do this. That's not the graph of what's going on. He didn't score less than 73. Okay. What I have underlined up there, the second part said, write an inequality to describe his possible score. What would his score have been? It would have been at least 73. So it would have been 73 or everything greater. Could he have scored 73 according to the directions? Yes. So how would we represent the number 73 too? Or also? Or equal to? And so it would look like this. X is greater than or equal to. And in a graph, it would look like this. If you see something, this will come more into play when you get into geometry and algebra 2. Some of y'all are going to algebra 2. An open bubble means not or equal to. If you ever see a parentheses, like graph going like that, that is the same thing as an open bubble. So if you ever see that, don't freak out. That's what it means. So had I graphed it and it looked like this, this would mean the same thing. If I put a parentheses, I won't do it in here other than right here just to show y'all if you ever see it. That means not or equal to. I'm sorry, I actually said it backwards and wrote it backwards. That means not or equal to. Since we have right here, since we have a closed bubble, that is a bracket. So if you ever see a bracket with it, so at 73, that means count the number 2. So if you ever see that, don't freak out. Bracket versus a parentheses. We'll use open and closed bubbles in here. Okay, here's number 1 on your checkpoint. It says you must be 17 years old or older to vote in the town election. Write an inequality to describe the ages of people allowed to vote in the town election, and then graph the inequality. Okay, so we know it's going to be X and we know it's going to be 18. We just have to fill in something to represent what's going on. 18 or older, that's what it says. Sometimes you're going to have to underline stuff to make it make more sense to you when you're looking at paragraphs and stuff like that. 18 or older. So if you're thinking about the number line, you don't have to get fancy. You just got to show that it's a positive number. You know that it's going to have something to do with the number 18. So you can circle 18. So, or older, that means the numbers are going to be bigger than 18. We know that numbers get bigger as they go this way and smaller as they go this way. We've been looking at that for a long time. So we know when we shade it, we're going to shade everything going that direction. But it says you must be 18 or older. So in this case, we want to count the number 18. So we're going to color the bubble in. Okay. When we show a graph of that, we're going to show greater than, and just like the last one, or equal to. Now, when we've been solving equations for the longest time, if we had something that looked like this, 3 equals x, this would be fine. What I mean by fine is we know how to read this. We know how to read this as x equals 3. We just read it from the variable. When you're talking about inequalities, it makes it much, much easier. 3 is greater than x. It makes it much easier if you just reverse them. X goes on this side, 3 goes on this side, and then notice the big mouth is pointing to the 3, and the point is pointing to the X. Just make sure you reverse it. When you reverse each side, the symbol switches with it. And it'll make all your graphing and stuff make a whole lot more sense and make it a whole lot easier. Okay, this is a big list of transformations. It said transformations that produce equivalent inequalities. This is just like equations for the most part. There's this one change when you're talking about multiplying and dividing by negative numbers. It says add the same number to each side. So if you have x minus 3 is less than 5, you add 3. We know how to do that. We get x is less than 8. Those are equivalent inequalities. The next one is subtracting the same number from each side. Again, just like as if that had said x plus 6 equals 9, this time it says x plus 6 is greater than or equal to 9. You undo the plus 6 by subtracting 6 on each side. You get x is greater than or equal to 3. Now, what people do a lot is they confuse which one is this and which one is this. Which one's less than, which one's greater than. And you'll notice when I call on people, they'll be hesitant to read it sometimes because they know everything except what to call each one of those. If you look at this first one, if you kind of just tilt your head a little bit, you can write the word less, or you can write the phrase less than with it. This one right here is less than. Notice it points to the smaller numbers. You can't do that with the other one. So the other one is greater than. So if you ever get confused with the two, you can write less than. The next transformation is multiplying each side by the same number. 1/2 times x is greater than 3. That's multiplying by 1/2, which is the same thing as dividing by 2. You know how to cancel out divide by 2. You multiply each side by 2. So x is greater than 6. Notice we're multiplying, but it's by a positive number. I'm meant to leave that one open for you too. By a positive number. Dividing each side by the same positive number. We have 3 times x is less than or equal to 9. Divide by 3 on both sides. X is less than or equal to 3. Notice that the symbols are staying the exact same direction. This one is saying greater than. It's remaining greater than. This one is saying less than or equal to. It's remaining less than or equal to. You're not changing any of that. Until you get to the next one. It says multiply each side by the same negative number means you have to reverse the inequality symbol. So negative x or negative 1x, when you divide by negative 1 on each side, that gives you a -4 number, and that less than symbol flips and becomes greater than. Or actually, their instructions are kind of backwards. It's saying to multiply by a negative number because this is dividing by a -1. It's the same thing. And the same thing is true for this one. When you divide each side by the same negative number, reverse the symbol. So that's what I just showed you. Divide by -2 on both sides. And less than or equal to becomes greater than or equal to. Notice the or equal to part stays. It just reverses. Here's example number 2. We'll go quickly through these because they're real simple. Notice out to the side it says check several possible solutions to see if your answers are true or not. Solve x plus 11 is less than or equal to 7. You want to undo plus 11, just like as if it was an equation. You subtract 11 on both sides. 7 minus 11. Now we're not multiplying or dividing, so you do not reverse the inequality. You subtract 11. This is just the horizontal method. Instead, I showed you the vertical method right above. 7 minus 11, you know, is the number -4, and the symbol stays the same. X is less than or equal to -4. So the answer is all real numbers that are less than or equal to -4. So when you graph this, again, you don't need to do all of this. Just 0. -4 is to the left of 0. That's how you need to show the relation to that. Less than or equal to colors the bubble in. Less than means go everything that direction. Okay, take about 30 seconds, solve and graph this one. Real simple. Okay, where we don't run out of time real quick. Undo the fact that this says +8 by subtracting 8. If you do it there, do it here. X, 1 minus 8, we know is the number -7. Think of where it is on the number line. We just subtracted. We did not multiply or divide. So we leave the symbol just like it is. X is greater than or equal to -7. When we graph it, we show its relation to 0. Greater than or equal to means you color the bubble in. And greater than means all of the numbers this direction. Notice this shows going the same direction.